So today I'm here with chapter 3, right? Chapter 3, first lecture, right? So chapter 3 is your current electricity, right? Chapter 3 is current electricity. Current electricity. Okay. Current electricity. So in previous chapter, right, chapter 1 and chapter 2, we have studied about charge at rest, right? But in this chapter, we are going to study about charge at motion, right? So basically, we are going to study things related to charge in motion, okay? So charge in motion, right? So charge in motion. Suppose this is your conductor. Suppose this is your conductor, okay? And this conductor is connected through a battery. This is your battery. This is battery. This is your conductor, right? This is positive terminal of battery. This is negative terminal of battery, right? So this one is positive. So this is also at positive, and positive terminal is at high potential, right? And this is negative terminal, and this is at low potential, right? So see, this terminal of the conductor is at high, and this is at low, right? So there will be electric field inside the conductor, right? Okay. So there will be electric field inside the conductor from higher potential to lower potential, right? Okay. So as electric field inside the conductor, higher potential to lower potential, right? You know, inside the conductor, what is present? Electron is present, right? So electron is present. That is, free electron is present, right? So suppose this is your electron. This electron is present inside a conductor, right? So electron is having charge, right? Okay. So due to that charge, see, now this electron is in electric field. Yes or no? So there will be force on this charge, right? So force start acting on this charge. In which direction force is acting? In this direction, and that force is Fe. Fe is force on electron, right? So as force acting on electron, right, this electron is start moving in this direction, right? So see, as electron is moving in this direction, suppose I am considering here area. Suppose I considering an area here. Suppose A is area, right? So see, as electron is moving, this is conductor, right? Conductor is having many number of free electron, right? So all electron is start moving, right? All electron is moving in this direction and coming to this one again, going inside the conductor is, so electron is moving like this, right? Electron is moving like this. That means some charge. So charge is crossing to this area. Yes or no? Right? Charge is crossing to this area, right? So and charge, another one quantity we are going to define, that is electric current, right? What is we are going to define? Electric current, okay? Electric current, okay? So as I discussed, charge is crossing this area, right? Okay. Then what is electric current? Electric current is rate of electric current is the rate of electric current is the rate of flow of charge, the rate of flow of charge, the rate of flow of charge across a cross section area, across a cross section area is known as electric current, okay? Known as electric current, okay? Known as electric current, okay? So now here charge is crossing to this area, right? Electron is having charge, right? So charge is crossing this area, right? Okay. So due to this crossing of charge to this area, there will be current, right? And how current is defined? The rate of flow of charge across the cross section area. Cross section area is known as current, right? known as electric current, right? So electric current is basically represented by I, right? So from this definition we can write I is equal to Q by T. So Q by T. So this is your, and Q is what? Charge crossing through this area in time interval T, right? Okay. So this way we are able to define current, right? So next we are going to talk about what is the unit of current, right? Okay. So unit of current. So you can see here current is equal to Q by T, and unit of Q is coulomb, right? And T is time, right? T is time, and which is unit is second, right? So unit will be Q by second, right? Or we can call it ampere, and which is in short written by A. So unit of current is coulomb per second or ampere, right? So these are the two unit of current. Okay. Now you can see here, as electric field is in this direction, electron is moving in this direction, right? And electron is moving in this direction, right? The electron is moving in some direction, right? Okay. So there will be some direction of current, right? So current is also having direction, right? Then what is direction of current? That one we are going to study, right? So next, direction of current, right? So direction of current is along the direction of electric field, right? So this is the direction of your electric field. So direction of current will be in this direction, right? Okay. So we can also define direction of current in terms of electron, right? So direction of current is opposite to direction of motion of electron, right? Electron is having negative charge, right? So we can also call like this: direction of current is opposite to the direction of motion of negative charge, right? So we can write here current is also having direction. Current is also having direction, but it is a scalar quantity. Now you can see here current is having direction, but it is a scalar quantity. Why it is a scalar? You know, for vector, three things is required: magnitude, direction, as well as follow the vector law of addition, right? Vector law of addition, right? So current is not following that law, right? Vector law of addition is not following by current, right? So that's why current is a scalar quantity. Okay. Now, next, one thing is clear: current is also having direction, right? Then what is direction, right? So next, direction of current is along the flow of positive charge, and opposite to direction of flow of negative charge, right? Flow of negative charge, right? So suppose if electron is moving in this direction, electron is having negative charge, so your direction of current will be in this direction, right? So for this conductor, direction of current is, this is your direction of current, okay? Because electron is moving in this direction, right? And electron is having negative charge, and direction of current is opposite to the direction of flow of negative charge, right? So now, and if charge is positive, so direction of current will be along the direction of positive charge, right? So somehow you are able to understand what is the direction of current, right? Okay. So next we are going to divide current into two parts, right? We are going to define current into two parts, right? So first one is instantaneous current, okay? Instantaneous current, and instantaneous current is written like this: I, right? And another one is average current, okay? Average current, in short we can write it IAV, right? So these two things we are going to study, right? Instantaneous current. In previous classes I have discussed, in previous class, that means in class 11, right, I have discussed instantaneous velocity, right? What was the definition of instantaneous velocity? Velocity at particular instant of time, right, is known as instantaneous velocity, right? So similarly this one is also defined like that, okay? So value of current at a particular instant of time is known as instantaneous current, right? Okay, so instantaneous current, in previous class velocity was, instantaneous velocity is defined like this, ds by dt, right? So similarly here your instantaneous current is defined by I instantaneous is defined by dq by dt. This is your formula to calculate instantaneous current, right? Similarly we can write for average also, right? So I average is equal to delta q by delta t, right? And delta q is amount of charge flown, delta q where delta q amount of charge flown in time interval delta t, right? So delta t is time interval and delta q is amount of charge flown in that interval of time, right? So now I'm going to take one question on this one, right? I'm going to take one question. With the help of that question we are going to calculate instantaneous current as well as average current, okay? So now I have to write the question, okay? So first you wrote all these things, okay? And after that I will write the question and then I will solve the question, okay? So first you wrote it down, okay? So now I have written the question, okay? So now I'm going to solve the question, okay? So you can see charge crossing a cross section of a conductor at time t is given by this equation, right? And we have to find instantaneous current. We have to find instantaneous current, right? And in second question we have to find average current, right? Formula is already written on the blackboard. Instantaneous current is equal to dq by dt, right? So we can write here dq by dt, and your q is how much? This one, right? So just we have to substitute the value of q. So 3t square plus 5t plus 5, and how much value will come? Differentiation of 3t square, how much? 6t, right? And this is 5t, differentiation will be 5, and this is 5, this is constant, so differentiation will be 0, right? So this is instantaneous current is coming as a function of time, right? In question they asking what? At t equals to 2 seconds, right? So we can write here I instantaneous at t equals to 2 seconds. Just we have to substitute value of t in this equation, right? And t is how much? T is how much? T is 2, right? So plus 5. So how much value is coming? 12 plus 5. That means 17. And this is current. So unit will be ampere, right? Okay. So we calculated instantaneous current. Next we are going to calculate average current, right? So average current. This is your formula, right? So find average current. Okay. So this is your question number 1, right? And now question number 2, average current. So average current, two things is required: amount of charge flown, right, as well as time interval. Time interval is given here 0 to 2. That means time interval is 2 seconds, right? So further we can write here. So I average equal to Q at 2 seconds, right? Okay, first I have to write the formula. Okay, delta q by delta t. This is formula, right? Okay, and delta q is what? charge flown in this time interval, right? And what is charge flown? Charge flown is basically equals to charge q at 2 second minus of q at 0 second, right? And divided by 2 minus 0. Time interval is 2 minus 0, right? Now you can see here q at 2 second. How we can calculate value of q at 2 second? Just substitute the value of 2 in this one. Just substitute value of time in this equation, right? You will get current at 2 second because charge at 2 second, right? Here charge is given as a function of time, right? And what our goal? Our goal is calculate charge at 2 second, right? And charge at 2 second is we are able to calculate by substituting this value of time in this equation, right? So further we can write, if I am going to substitute 2 second in this equation, so see what value will come? 3 t square, right? And t is how much? 2. So 2 square, okay, and 5 into 2 plus 5, and now q at 0 second, right? That means we have to substitute in place of t, we have to substitute 0, right? So this is becomes 0, this is becomes 0, right? Only what will come? 5, right? So t equals to 0 second, current is how much? 5, right? And here 2 minus 0 is 2. So this 5 cancel, right? So finally we have 3 into 12 and plus 10, right? So we can write here, okay? So 3 and 4, 12 plus 10, right? 12 plus 10 is how much? 22 divided by 2, that means 11, right? So answer is 11 ampere, right? So this is current, so unit will be ampere, right? So if question will come like this, you are able to calculate instantaneous current as well as average current, right? With the help of these two formula, okay? Next we are going to discuss current density, okay? So first you note it down, and next I will discuss current density, okay? So next I am going to discuss current density, okay? Current density, and current density is represented by J. See, J vector. So current density is a vector quantity, right? So current density now we are going to discuss, okay? So suppose this is your conductor, right? And this conductor is having area A, right? This conductor is having area A, and current passing through this conductor is I, right? So current density will be, you can see here, this current is passing perpendicularly to this area, right? Suppose this is your wire, right? And current is passing in a wire like this, okay? And if current is passing perpendicularly, right? So if current passing perpendicularly is I, right? And area is A, so current density will be, current density J will be I by A. Current density J will be I by A, right? So basically current density is amount of current, right? Current density is what? Amount of current passing perpendicularly through a cross section area per unit area is known as current density, right? So we can write here definition of current density, right? So amount of current passing perpendicularly, amount of current passing perpendicularly per unit cross sectional, amount of current passing perpendicularly per unit cross section area, right? Per unit cross section area is known as current density, okay? Is known as current density. So amount of current passing perpendicularly per unit cross section area is known as current density, right? And current density is equal to J is equal to I by A, right? Okay. So next, current density is also defined in average current density as well as current density at a point. Okay. So now we are going to discuss that one. So suppose this is your conductor. Again, this is your conductor, right? And through this conductor, I current is flowing, right? Okay. But in this one, there is a condition. That what is condition? Current is not uniform, right? In this one, current was uniform, right? But here current is not uniform, right? Okay. So suppose we are going to calculate. Suppose I am going to consider an area here, right? This area is suppose delta I. This area is delta I, right? And current passing through this one is delta I, right? So current density for this area will be what? Current density for this area will be J, and that J will be delta I by delta A. So see, this is your average current density, right? This is your average current density, right? So for average current density, we have to use this formula, right? And where delta I is current flowing perpendicularly to delta A area, right? Okay. So suppose now there is a point on this area. There is a point on this area. Suppose this is a point P. Okay. Now there is a point on this area. Okay. Suppose someone is asking you, you calculated current density for this area, right? And that is your average current density, right? But someone asking you to calculate current density at a point, right? So another formula we are going to write current density at a point, okay? Current density at a point, right? Current density at a point. So in that case, current density at a point J is equal to, see here point, now point is having very small area. That means area of point is what? Infinitely small, right? So current density at a point can be written like this: limit delta A tends to 0, right? And delta A tends to 0, delta I by delta A, and this is what? Del I by del A. So this is formula to find current density at a point. Okay. So with the help of this formula, you are able to calculate current density at a point. Due to this, with the help of this, you are able to calculate average current density, right? And this is your general formula. Okay. So somehow I track this formula. Okay. So next, some more things I have to discuss. Okay. So first you note it down. See, amount of current passing perpendicularly per unit cross section area. Okay. Per unit cross section area. Okay, yeah. Per unit cross section area. Amount of current passing perpendicularly per unit cross section area is known as current density, right? So see now here, I pi is per unit cross section area, right? So here per unit will come. Okay. Okay. So now some more formula I'm going to write related to current density. Okay. So I have to draw this one. Okay. So again I'm going to draw. Okay. So again I'm going to draw conductor. Okay. So this is your conductor, right? And this conductor is having area A, right? So this is your conductor, okay? And current is passing perpendicular to this area, right? Perpendicular to this area, and area is delta A, right? Okay. And area is delta A, and current is passing is delta I. So here current density is equal to Current density J is equal to delta I by delta A, right? Okay, so this is your direction of delta A, right? Here you can see I as well as I current and current as well as area, both is along same direction, right? Area vector as well as current is same direction. That means current is perpendicular to this area, right? But suppose current is not perpendicular to area, right? Or area is not perpendicular to current. So in that case, how we can calculate J, right? So see, suppose the condition is like this. Your area is, this is your area. Now you can see here, suppose this area is also dA, right? So area vector is in which direction? Direction of area vector is, this one is your direction of area vector, right? Okay, and your current is in this direction, yes or no? Current is along the direction of conductor, right? So current is in this direction and your area vector is in this direction, right? Area vector is in this direction. So delta A is in this direction, okay? Area vector delta A is in this direction, okay? And this angle is given theta, where theta is what? Angle between current as well as area vector, right? Okay, so now here, suppose here you are going to calculate current density, okay? Here you are going to calculate current density. So how you are going, how we have to how we are able to calculate current density here? We have to find perpendicular area. Which area is perpendicular to this current, right? Because you know current density is equal to delta I by delta A, right? Where delta I is current perpendicular to this area, or we can say like this, area perpendicular to this current, right? Okay, so here we have to find perpendicular component of this area, and what is perpendicular component of this area is this one. This is the perpendicular component of area, right? And this area is how much? This area is delta A perpendicular, right? This area delta A perpendicular is how much? A cos delta A cos theta, right? Because this angle is theta, so this angle between these two is also theta, right? Angle between these two is also theta. So component of this area in this direction will be delta A cos theta, right? Now perpendicular area is, area perpendicular to this current is known, right? So suppose this is your, okay, this is your delta I. So current density is here. J is equal to what we can write? J is equal to delta I by area perpendicular to this current, right? And what is that area? Delta A perpendicular, and delta A perpendicular is I, and delta A perpendicular is how much? Delta A cos theta, right? So what formula is can? J is equal to delta I A delta I by delta A cos theta, right? So this formula is useful when area is not perpendicular to your current, right? But angle is given, then you are able to use this formula, right? So this expression further can be written like this: delta I is equal to J delta A cos theta. Yes or no? Right? Okay. And further we can write it J vector dot delta A vector. Okay. So this is one more formula, right? And now J is a current density, right? And that is vector quantity, right? And direction of current density is along the direction of current density is along the direction of current, right? So your current is in this direction, so your J is also in this direction, right? And angle between J and A is theta, so we can write it J dot A. Okay, so these are the some important formula which is related to your current density. Okay, So now I'm going to take one more question related to current density, and I will try to find current density. Okay, so now I'm going to solve this question. Okay, in this question two things we have to find, right? One is we have to find current, and another we have to find current density, right? And what things are given in the question, right? See, area is given, area, okay, and electron is given, this much number of electron is passing. Okay, so suppose in these questions they're saying that an electron beam has aperture this much, right? Suppose this is your beam of electron, right? This is your beam of electron, right? Electron is passing through this one, right? And this is having how much aperture? A is aperture, and A is how much? 1 millimeter square, right? Okay, and how many number of electron is passing? 6 into 10 to the power 6, right? That means n is given 6 into, okay, these two things is given, then we have to find current, right? And you know that first I am going to solve current, right? Current is I, and what is the formula of I? Q by T, right? Okay, T by Q by T, and Q is how much? Q is Ne, yes or no? Right? Q is Ne, right? And now N is given in the question. How much is the value of N? This much. So 6 into 10 to the power 6, and E is the charge on one electron, right? And that is equal to how much? 1.6 into 10 to the power minus 19. And time is how much? You can see here per second. Okay, we can write like this, per second. Okay, so now question is complete. Okay, an electron beam has an aperture this much, total this much electron go through any perpendicular cross section area per second, right? Per second this much electron is given, right? So time is 1, so T is 1 second, right? So by solving this one you are able to get the answer. Okay, so you are able to get the answer. So this is how much? 9.6 into 10 to the power minus 30. Okay, minus 30, and this is current, so it will be ampere, right? And next we have to find current density, right? Current density is J, and you know J is equal to I by A. I you calculated, this is your I, right? And J is, area is given in the question, how much? 1 millimeter square, right? So we have to convert this area in meter square. To convert into meter square, we have to multiply with 10 to the power minus 6. So I have multiplied with 10 to the power minus 6. So now this area is converted into meter square, right? So if I substitute the value here, so 9.6, right, into 10 to the power minus 13 divided by this area is how much? 1 into 10 to the power minus 6, right? So if you are going to solve it, right, if you are going to solve it, how much value will come? Answer will come 9.6 into 10 to the power 30. If this 6 will go up, so it becomes plus, right? So further we can write here minus 7, right? And unit will be ampere per meter square, right? So your current density is this much, right? And your current is this much. Okay, so this is all about your current density. Okay, so in next class I will discuss some new things related to this one. Okay, so this is all about today. Okay.